transition to solving quadratics by graphing. So yesterday we were graphing quadratics. Why is that useful to us? Because we can work with solving them. In chapter 8, we worked with quadratics and we solved them by factoring, by making the t-chart. So if the question would say, find all the zeros of the quadratic function f of x equals x squared minus 10x plus 24. If there is more than one zero, separate them with commas. If there are no zeros, click on none. Okay? Zeros meaning y equals 0. So we would have set this equation 0 equals x squared minus 10x plus 24. What would we have done then? Nope. You got to make your table, right? Your t-chart. You're going to multiply to get to 24, and you're going to add to get to negative 10. Do you know your factors?
Yeah.
What are they?
No,
Negative 6 and negative 4. So this would be x minus 6. This would be x minus 4. Then what did you do? Yep, we slash it, and we set them equal to 0. X minus 6 equals 0. And x minus 4 equals 0. Then plus 6, x equals 6, plus 4, x equals 4. And that's where we would have listed 6 comma 4. Remember doing that? Okay. Today, they're going to ask you to go the opposite direction. I want you to write the quadratic function whose zeros are 3 and negative 2. We're going to do the complete opposite of what we just did. So they would have told us our answers were 3 and negative 2. What is 3 and negative 2? X. X is 3 and x is negative 2. What do we do the step before that? We want it equal to 0. Don't just say flip the sign. We want it equal to 0. Why are you doing that? So how do I get x equals 3 equal to 0? Very good. Subtract 3, so you'd have x minus 3 equals 0. And add 2, so you'd have x plus 2 equals 0. What's the step before that? Yeah, those are your two binomials, correct? Before we slashed them, and what were they equal to? 0. Now, technically, should you multiply those? Yes. Is Miss Hoff going to make you? No. This is the function that you would give me. The complete opposite process of what you did up, up, up. I'm going to give you the zeros. You go backwards and tell me what you started with. First, that's what our x was equal to. Get them equal to 0. Put them back together. Now, how does this go into what we are talking about with graphing quadratics? Okay? Quadratic can be written as ax squared plus bx plus c equals 0, meaning y equals 0. Where on a graph does y equal 0 always? On the x-axis for all of your x-intercepts. So in other words, we are going to graph quadratic equations and then look for the x-intercepts. Quadratics can have different situations. You could graph it like this first one, where you have two solutions. You have an x-intercept here, and you have an x-intercept here. You could be in the middle one, where there's only one x-intercept. What is that point? The vertex, right? Or you could even have a situation where it's above the x-axis opening up and there's no solution. So today you're going to have different scenarios. You might say one solution and then tell me what the x value is. You might say two solutions and tell me both x values, or you might say no solution. It depends on what your graph looks like. So it connects to yesterday by, you got to know how to graph it before we even can look at it and identify the x and y x-intercepts, not y-intercepts, x-intercepts. Okay, Solve x squared minus 2x minus 8 equals 0 by graphing. First things first, it has to be equal to 0. Is it? Yes. Identify your A, B, and C. A is, B is. Okay, I was like, what? -2. C is -8. What is the first thing I do? We got to find our x of our vertex, right? X equals negative b over 2a. What is b? Careful. -2 divided by 2 times 1. Now a -2 is positive. So I really wind up with 2 over 2, or in other words, x equals 1. Okay, so in my table, how many points am I graphing? 5 points. 1 goes in the middle. What other ones are you going to graph? 2, 3, 0, -1. I'll do 1. You guys do 2 and 3. You guys do 0 and -1. Okay? Plug in 3. What'd you get? -5. Yes. And plug in 2, you got -8. Plugged in 0, you got -8. And you plugged in -1, and you got good or bad? Good, because they should match, right? Okay, plot those points. Now, the whole purpose of graphing this is to solve by graphing. What am I looking for? It equals 0. What equals 0? Y equals 0, which Alexa reminded us are really just our x-intercepts, yes? So I need to graph this, and this is where Alex is going to be way better than the human, right? Okay, when you click the button on Alex, it's going to graph this really accurately and give you the appropriate points. Like, I'm not going to lie to you, this is probably supposed to be like this. But then you would identify just the x values of where those are. Now, you guys are looking at like, line doesn't look like that, right? When you drew that U shape, that's okay. That's where Alex is going to be it's going to be right where you're going to know exactly what to pick. So I would say this one is what? 1, 2, 3, 4. 1, 2, 4 and -2. Now, it could be different on your graph. Alex will help us avoid that. Okay. Flip it over. Top or bottom? Bottom. Graph it. On your own. Graph the bottom one. See what you get. Oh, this is nasty. What? You're the one that picked it! Okay, let's go back and do this together. Why do I say this is nasty? You get 3/4, right? Okay. Let's make the best out of Mason's terrible choice here. Okay, I have to pick 2 things above and 2 things below. What should we pick? Okay, if I pick 1, what do I have to pick below? A half. No. They have to be equidistant from the vertex. 3/4 to 1 is a quarter more, so then you have to go a quarter less. Then what are you going to do? I would go 2. So what's 1 away from now this way? -1/2. Yes? Now let's be real. In the graphing world, is it going to make most sense to have a decimal or a fraction? If I gave you 7/22 and you need to put it on a graph, you know where that is? Right, you can probably put it on a number line easier. Okay, so let's change these to a decimal. Instead of 3/4, we could go 0.75. Instead of 1/2, we could go 0.5. Instead of -1/2, we would go -0.5. I'll take the vertex. You guys get 0.5 and -0.5. You guys get 1 and 2. You got the easier.
No, they did.
Yes, they did. Well, no, it's fair because the person dummy on our side was supposed to pick the question.
Sorry, I meant to go the other way.
It's okay. We get 2 and 1. It's fine.
Yes. 2 and 1. I used to not let kids change it to decimals. How's that make you feel? You should feel special.
Very special.
Bless you.
I feel like that's not right for 2.
No, that's what I got for 0.75.
Oh yeah, shoot, I was doing
But on Alex, you have to type it in as a fraction.
I don't think they'll have it. Yeah, you could, but I don't think they'll have you have any better fractions. All right, 2.
2, 7.
1, 4, 0.5, 4, -0.5. Was nasty, and now it's not so bad, right? Plot those points. Oh, make it as close as you can. It's an estimation. Graphing is not perfect. Graphing is not perfect. I bet you are. Why do you panic?
That's not right.
It's not over the x-axis. So what's your answer? No solution.
I probably could have just said that because that's.
It doesn't because they're decimals. It's not because they're decimals. Conversation had over here. Chloe said when you need to put when you pick, like tell the Alex to put in the XY pair, you have to put it in as a fraction, right?
Yes.
Okay. So, well, if there is such a thing, obviously you'll want to keep it a fraction, but I don't think there'll even be one on there. Okay. So your answer, you're going to have work to turn into me today, and you're looking at where they cross the x-axis. Go to it. Make sure you turned in yesterday's work. I'm going through it right now.